Unit 17, Part 1. So welcome to the fourth part of our course. Section 17 starts Part 3 of Klenk's book on relational predicate logic, but for us it's the fourth part of the course. Parts 1 and 2 were on sentential logic, Units 1 to 6, culminating in truth table proofs for an argument's validity. We did exam 1 at the end of Unit 6, then Units 7 to 9 on proofs in sentential logic, then you took exam 2. Units 10 through 16 were on monadic predicate logic, or quantifier logic, monadic one-place predicate logic, and you should have just completed the third exam, which was on the material from Units 10 to 16, and now we're starting the fourth part of the course on Units 17 and 18 only, and after that we will have a fourth exam out of just 100 points instead of 160 like the previous exams, and that will be the end of the course. Let me remind you what I've explained several times, and that says it is explained in parts H and I of the syllabus. H and I of the syllabus. That this fourth exam is optional, okay? So having completed the third exams, you've done everything that is absolutely necessary assessment-wise for the course. If you calculate your grade according to the grade maze as explained on the syllabus, right, you have your points out of 540, 3 exams for 160 points each, 5 quizzes, 30 points, 5 homeworks, 30 points. That adds up to 540. Take your percentage, whatever the corresponding grade is. That's the worst grade you can get, and if you don't do anything else and turn off this video right now, you will receive that grade, right? If you have 80.1, that's a B minus, right? You got 88.3, you will get a B plus. Anything over 90, you get an A minus. The one exception, of course, is you cannot get an A without taking the fourth example. Again, there are 2 conditions on getting an A, not just an A minus, but an A, right? So if you don't take the fourth exam, the best grade you can possibly receive is an A minus. Even if you've got 100%, you get an A minus, unless you take the fourth exam. 2 conditions of getting an actual A. One condition is you have to take this fourth exam on the material we're covering now, Units 17 and 18, and you have to get at least 75 out of 100 on the fourth exam. And the second condition is your overall score, your overall percentage has to be 92.4% or above, okay? So that means that if you're here, you should only really be aiming to take the fourth exam if you are within shot of an A, right? So here's what I recommend. Calculate the number of points you have out of 540. Imagine you got 100. Imagine you're going to get 100 out of 100 for the fourth exam, right? Add that up. Now you have a total out of 640. Is the overall percentage 92.4% or above? If so, you are within shot of an A. You should go for the fourth exam, and you should study Units 17 and 18 and attend to these videos. And if that's you, welcome, you're in the right place, and welcome to Top Gun. Top Gun, you're the best of the best. You are the A students, and you're in the right place. Okay, so yeah. Just as corny as I am in lectures on my videos. Okay, so relational predicate logic. If you recall, we motivated the introduction of monadic predicate logic back in Unit 10, our quantifier logic. We motivated the need to begin on a new system of logic. We had done sentential logic. We were now starting monadic predicate logic, and we motivated the need to have this new system of logic by presenting you with arguments that were clearly valid, where the validity was very obvious to our minds, and we could clearly perceive that the conclusion followed of necessity or the truth of the conclusion followed of necessity from the truth of the premises. What's that flying behind me? Right? But we could not formally capture the validity of that argument with the resources of sentential logic, right? Where we took simple sentences as just atoms of themselves, we couldn't do it. Dan is Australian, all Australians are surfers, therefore Dan is a surfer, right? Sentential logic, representation, formal representation, is P, next premise, Q, conclusion, R, right? No formal grasp, no formal comprehension of the validity of the argument. So we had to introduce monadic predicate logic, which we were just calling predicate logic or quantifier logic, and we had the singular sentence, Dan is Australian, became the combination now, instead of just an atom, it became the combination of propositional function annexed to a individual constant, uppercase A, lowercase d, Dan is Australian. All Australians are surfers became for all x, if AX then SX, and so on. And we introduced our 4 new rules in Unit 15 governing the addition and removal of quantifiers. And we could formally prove, and thus formally grasp and understand, the validity of that argument. Same thing is true here in Unit 17. Why do we need to go beyond monadic predicate logic? Monad, one place predicate logic. Why do we need to go from monadic predicate logic to polyadic predicate logic? Poly meaning many, or many place predicate logic, which we also call relational predicate logic. Again, for the same reason, there are plenty of arguments, the validity of which is utterly clear to our minds, right? We can look at the premises and conclusion and say, oh yes, it is necessarily the case that if those premises are true, that conclusion is also true, right? We can see clearly that the truth of the premises forces the conclusion to be true, right? We can see that the conclusion follows from the premises. We can see that we can indeed infer the conclusion from the premises, however you want to say it, right? We have arguments like that, where that validity, which we see, we cannot grasp with the resources of merely one place predicate logic. Okay, so thus we need, again, some more complexity. We need another level of analyses. We need more machinery to formally grasp this validity, which we see but cannot reach with the resources of one place predicate logic, monadic predicate logic. So the argument that Klenk presents you with on the first page of Unit 7, page 313, is this argument up here, okay? Some people don't like any dogs. Second premise, puppies are dogs. Therefore, conclusion, some people don't like puppies. Okay, so you should look at that and say, if it's true that some people don't like dogs, if it's true that puppies are dogs, then, right, some people don't like puppies. That's true, yes? That's a valid argument, right? Now, if we attempt to symbolize this argument in monadic predicate logic, this is what we get. This is how we would have to do it, right? What is monadic? So now we're going to start to see how we are limited in our formal presentation. Monadic predicate logic, we've only got one place predicates, right? And that's going to be the limitation that we're going to transcend, okay? So monadic predicate logic, the first premise gets translated as, right? So all we have available is one place propositional functions, okay? Some people don't like any puppies would be translated as so. There exists an x such that x is a puppy, px, x is a puppy, px, x is a person, px is x is a person, lx has to be X likes dogs, right? That's going to be where the problem, right? The problem will be in not having a sophisticated enough and accurate enough analysis of the liking predicate. We're going to see that it is actually ontologically a two-place predicate. I'll explain that in a moment for the next video. So LX has to be X likes dogs. So the first premise is there exists an X such that X is a person, and it's not the case that X like dogs. Some people don't like dogs. Puppies are dogs, so all puppies are dogs. UX, X is a puppy, DX, X is a dog. For all X, if X is a puppy, then X is a dog, right? And then our conclusion would be down here. KX is X doesn't like puppies, right? So we've got, there is a person who doesn't like puppies, right? So just the thing to take away from this is how we have failed to formally grasp or formally comprehend the validity of the argument. And there's no prospects for a proof, right? For one thing, the predicate KX, X likes puppies, so it's not the case that X like puppies, is not connected, right? Is not connected with anything that came before. We had LX for X likes dogs, KX for X likes puppies, right? So they were both likings, but because we've only got a one-place predicate, and one of them is liking one object, dogs, and the other one's liking the other object, puppies, we have to give them different one-place predicates, okay? So what we're going to do is introduce two-place predicates, and we're going to grasp the connection between liking dogs and liking puppies, right? So I'll come back in the next one and start on this. So these two things, you've got, this is presented on 313 at the beginning of Unit 17 of Klenk, showing you why we can't formally grasp the validity of this argument at the top and why we need to move beyond it to a new mode of analysis. The very long, chapter 17 is big and long, many parts. Chapter 18 is short. Chapter 18 is on proofs. This is presented at the beginning of chapter 18, okay, page 342. And this will be this symbolization of the premises and conclusion of this argument is kind of where the whole of 17 aims at. And when we get through all those bits, the actual proof, well, actually, she speaks as if it's very easy. It's not very easy, but there isn't that much more to it once you do get a handle on the kind of symbolization that goes on in two-place predicate logic. Come back in part 2 and continue.